Okay, so we're going to start to continue on Shell Lab where we last left off. I believe when we last left off, we had just gotten past trace 14. So trace 14 was when we had implemented the ability to go ahead and handle process groups as opposed to process IDs. Now, of course, because we were using the negative sign in our PID for each of our kill calls, for each of our kill functions, whenever we used the kill function, that already did that job for us. So when we ran traces 12, 13, and 14, we were able to bypass those without much implementation change. So that leaves us to the next trace, 15, where up until now, we've been doing minimal implementations into our tiny shell. And as a result of that, as a consequence of that, we've been able to pass traces. However, we haven't done any error handling. And now we're finally getting to a trace that's going to check for errors that might commonly occur from the shell, where the user might supply inadequate or incorrect or malformed commands. And so we should do something in response to that. We're going to see we should do something in response to that from the reference shell, because when we go and look at the trace, we're going to see just that. But before we start looking at trace 15, let's just make sure that we're up to trace 15. So I'm going to open up our tiny shell, our shell lab. So let me open this into a terminal, or actually let me link in here and then open this into a terminal. And then what I'll do is I'll move this off to the side here. Let me go into here. Perfect. Let me run our check. And while we're waiting for this check to proceed, because now we've moved a decent amount into our traces, I want to just prove that we've gotten our point allotments up into this point. So we'll let that run in the background. Let's take a look at the motivation behind trace 15. So trace 15, in order to pass it for our tiny shell, we're going to have to check our error handling for bad inputs. And so we can see trace 15 looks quite dense. Our header comment says simple error handling. Let's take a look at some of the output here, and then we'll do our comparison contrast between the expected output from our reference tiny shell and then our behavior that we have currently from our tiny shell. So we can see this first call here, dot/bogus. So we're trying to invoke a command that is a non-existent program. So we would expect when we try to do that from our tiny shell, we'll likely expect to get some kind of error message from that, which we're not doing anything with. And if we are doing something with that from a prior slide, I'll in the future omit that so that that gets handled here. So we're going to pretend like we haven't handled that if we did, because it has interesting consequences about how we have to think about that. Then we have a background job that we're spinning up, the MySpin application for 4 seconds. We're going to have our test harness sleep for 1 second. Now we're going to call the built-in commands background and foreground. Now recall that both background and foreground will resume a job or move a job into the to become a foreground job, foreground process, or a background process. However, it requires either a job ID or a process ID. And here we've omitted either. So this should likely go ahead and result in an error message as well. Then after that, we're going to call the built-in command again with a alphanumeric letter. Now recall, if the PID is in the form of an integer value, which is a valid argument to FG or BG, or we can use a job ID, which uses as its initial character a %, but thereafter it should be a numerical value. So the alphanumeric value of A is clearly a malformed argument. It's an inappropriate value to pass as an argument, and so that should also generate an error. Then we have a call to foreground and background providing an adequate legal process ID. However, this is a process ID that's too large and will be non-existent. So this should also result in an error. Then we're going to have a call to foreground using a job ID. Now, in this instance, the job ID will be out of bounds as well. We've tried to invoke two applications, and so here one was bogus, so this is not a real application. Then we have this one here, we have this single application, so there should be no job to speak of, so this should actually generate an error since that should be out of bounds of the jobs list at the time that we run that. This one seems like it's plausibly legal, a foreground to job ID 1. Then we will tell our test harness to sleep for 1 second. Then we will send a stop signal to our shell to go ahead and stop that process. Then we will then be able to go ahead and issue a background on job ID 2, which again, there is no job ID 2, so this should also result in a error message. Then here we will resume our stop job in the background since job ID 1 should be legal. And then finally, we will print out the state of jobs. So there's a long list of commands here, but we can see presumably it's all to go ahead and just test what kind of responses our tiny shell does when we provide it inputs that are wrong, that it can't successfully execute on. Okay, so with that said, let's jump back over here and we can see we have our final current state of everything here. You can see here for our first several traces all the way up to 15, we passed, and this is where we last left off. So perfect. Our code should be compliant with where we expect it to be. Let me clear out of that. Now, let me go ahead and open up our tiny shell because this is what we will be coding in. Let me jump this over here. Perfect. Okay, so let's take a look at what we currently have. I'm actually going to do the side-by-side because it's easier, but then we'll verify inside the terminal, see that it's correct. So if I were to go ahead and make the reference test 15, I should get a lot of output, and we're going to step through this a little bit at a time. If I go and make our test 15 for just our tiny shell, not our reference shell, we're going to see I get a lot less output. And so we could see a lot of this output are going to be the error messages that we should be sending to the standard. It's displaying out from our console to alert the user that they provided bad input into our tiny shell. So if we start at the look, and let me run these in isolation so we can make sure that our own code is at the same level. So I'm going to do reference shell first. Yep, around 15. So let's make that. So we get the header comment that's echoed out. Then stepping through, like we said before, we're going to try to make that call to that bogus application. So we get a message ./bogus command not found. Then we're going to spin up that background application, my spin, for 4 seconds. So we're going to get the message from that. Now we're going to get these 2 error messages. So now we can actually see, we can use the reference shell to see the format in which our console error messages should be. So here we can see a foreground command requires either a PID or a job ID, and the background command requires a PID or a job ID. So of course, that's when we try to issue with the alphanumeric, when we issued BG and FG with no arguments whatsoever. And now the instances where we try to invoke BG and FG with an alphanumeric value, something outside the bounds of a integer value or a job ID, which starts with a % and then a integer value, then we would get these error messages. Now, if we try to go ahead and do something in relation to a malformed PID, so if the PID is out of bounds, if it's not a PID that exists, so it's a valid PID but it doesn't exist, then we'll say no such process, and we'll give it the PID that we attempted. And that's both on BG and FG. Then here, this is the instance where we tried to go ahead and move to the foreground a job ID of 2, and we said there's only one job in the job list, so that's causing that error. Then this was where we tried to move the job ID 1 to the foreground, and that worked. Now we're going to try to move the job ID 2 to the background, and recall that we sent the stop signal at this point, but again, we can't move a job ID that's non-existent. So we get that error message again. And then here, we're going to go ahead and have successfully moved our job ID of 1 to the background, where it can then start rerunning. It's sent the continue signal. And so therefore, when we call jobs, we're finally going to get that output from jobs. So stepping through, we can kind of see where all of our output comes from. Now, if I currently go into here with my make on my tiny shell, the current thing I'm getting here, I'm getting the echo, right? And then I'm not getting the error message on the bogus. I'm getting the fact that we did successfully spin up my spin, that external application, 4 seconds as a background job. And so then we're going to go ahead and have this stop where it just gets terminated. And then we're going to have what's the printout here too. So we have a couple of things happening here. So when we go to tackle a lab like this, one of the best things that we can do is step through line by line from what we have in our expected behavior and see if we can't build out our observed behavior, because there's a lot going on here. So we shouldn't try to tackle it all at once. We're going to iteratively improve our code base, a set of lines at a time, a set of errors at a time, until we have complete correspondence between our reference test and our test, our tiny shell and the reference shell. Okay, with that said, let's move to the first line, the first output that's different, and that's going to be this error message where there was a command's not found. There's no application called bogus. So if we are giving a application name that is incorrect, then we have to issue a error message in this regard. So where do we go to evaluate this? Well, this is some data that we already have access to in our eval function. So let's jump to our eval function. Let me clear this too. So what I'm going to do is I'm going to jump to my eval. So this is our eval function as it currently stands. Now, recall that external applications, anything that's not a built-in application, is going to go ahead and fork out a process, and then it's going to take that child process ID. So if the PID is 0, then we're going to go ahead and set it into its own process group. And then we're going to go ahead and call this the executable vector, where we're going to go ahead and override the clone, the fork process, with the actual call to the process that we want to do, or call to the application that we actually want to do. So recall that the application command is going to be the element 1, or the 0th index into our argument vector. So we're going to pass that as our first argument. And then as a second argument, we're going to pass it the entire argument array. And so it's going to attempt to invoke and run that, take that forked process and run that application there. And recall that it's going to go ahead and provide back a value. And if it provides back a value that is less than 0, then that means an error occurred. And so up to this time, all we did was blindly expect, hey, run this application. This is my MySpin application. This is my MySplit application, and it would run in the background. This is the first instance where we're trying to run an application that is going to result in a negative value being returned from this system call. And since we're already saving the status, all we have to do now is set up a check. So let's try this. So we can put a selection statement here. There we go. And so inside this selection statement, let's check the condition. So the condition is going to be on the status from this call to the to execute on this on the argument vector. So if the value of that is less than 0, that means that an error occurred while trying to execute this, then we can go ahead and provide feedback, some kind of a prompt of sorts to the or an alert to the message to the user. So here I'm going to use a printf. Inside the printf, recall that the format of this is we're going to give the command that they tried to provide. So %s will represent that command, then a colon, then we're going to do command not found, and then we're going to do new line character, and then we have to go ahead and replace this placeholder value with the actual command, and we have that command recall inside of our argument vector at index 0. Okay, so this gets us there partially. This looks good, but let's see what happens when we run this. Because what we want to do is we want to try to get this output, on here. So let's see where we're at. So let's recompile our code. Okay, compiles fine. Now let's do a make. So let's make test 15. We're going to make that. We get the echo of our header. We're getting this command here, but look at this other output that's generating from that at this time. So we can see that we're getting this call to MySpin. Then we're getting that this job was terminated by signal 11. And then we're getting this call here. How does that compare to what we had? So here, these two are looking fine so far, right? In terms of our observed behavior, we did get this bogus command. Perfect. We're now getting this call to MySpin, which is what we want. Yeah, so these two lines. And then we're jumping to job 1 terminated by signal 11. Now, we have an issue here where we're generating a second printout of this here. If I were to continue implementing from this point, I'm always going to keep getting this duplicated print. And so to kind of save you some headaches and to kind of give you a concept, and if I remember, I'll comment this out so that you can see the importance of this next step, but we want to not have this line here. That line clearly should not be there throughout the entire juncture. Let's think about what's happening here because we're missing one line of code. What we have here is we're creating a forked process. Okay. Now, inside the child of the fork, we're going to set it to its own process group. Then we're going to go ahead and send to the system call the ability to go ahead and run the application we want in this fork process. And if it's successful, it's going to return a non-negative number. And then it would run that process until completion, and then we would do something else. Now, if it errors, it's going to give a negative value, but we still have that forked process, don't we? Right? It's still been forked, and we haven't successfully been able to override the current forkedness of it. So the current parents, remember, creates the child is a clone effectively of the parent until we override it with a new application to run. If we fail to give it a new application to run, it's still going to have the signature of its parent. So when we check this and we say, oh, the status was a negative number, let's go ahead and print this command not found. We also have to then make that process go away. And how do we make a process go away? Well, the same way we make the process in our quick command to go away, we can use a system call to exit. We should do that on this fork process as well. Because if we don't do this, it's going to cause massive headaches later on. Okay, and then we got to give it a numerical value, since now we are exiting because of a unsuccessful run. Since this isn't a successful completion, we will use a status code. We'll use status code of 1 to illustrate that this was a exit due to an error. And so now with that in there, let's compare. Let's clear this. Let me go and make my test 15. And oh wait, I have to compile. Can't forget, every time we make changes to our code, let's recompile. And now we will go ahead and run our test 15. We get the echo to the comment. We get that, hey, this is a bogus command. And now we're going to run this command in the background. And so instead of getting that error message with signal 11, because we were spawning an incorrect, well, now instead of getting that that error signal, the interrupt and then the double print, we've successfully killed that process. We've exited out that child process whenever we have generated an incorrect application name or command name for our shell. So this is what we want. Okay, so let's see here. This is the implementation. We just walked through this. This was inside of our eval function. And here, now this is where we should be at. We successfully have the echo header comments. We successfully have this idea that this bogus application is command not found. We successfully spin up as a background process our myspin for 4 seconds. Now, the next thing we're going to have to do is take care of this foreground command requires PID or job ID error message, and this background command requires PID or job ID, which we don't get at all currently. So now these, if we think about what function is responsible for evaluating and determining the correctness of this input, is going to be inside our do bg fg function, right? Because that's where we're really managing all of the logic for being able to move a process to the background or foreground and then having to continue. So what we can see here is we can just make a simple check. Up till now, we just kind of trust that when BG or FG is issued, that it's followed with an argument. Now recall, one thing that we did when we implemented this, we created some very readable variables to illustrate how our command line is effectively imputed into our system, where the at index 0 of our argument vector would represent the command, and then the second or the second element there, the element at index 1 in our argument vector would then be the parameter or the argument that's being passed to that command. So since we have our variables set up here, we simply check initially to see, okay, is our param null? Does it not have any value? And if it is, then that means we've only gotten the command by itself. We didn't get an argument associated with it. So now we can go ahead and produce this error message where that command requires an argument of either a PID or a job ID. And then we'll have to return out of our function when that's done, because we don't want to do any more logic. We haven't been given enough input to be able to do anything in response to this request. So we'll just exit out of this function then. So let's jump into our code and let's go to our BG, do BG, FG. So let me jump there. There we go. Okay, so here it's pretty simple. Before we do anything else in this function, what we want to do is we want to check if that parameter is null. Perfect. And then if it is, then what we want to do is we want to print out that very specific message that is given to us from the reference shell. So it's going to be %s command requires PID or job ID argument, and then a new line character. And then we will go ahead and replace this placeholder value of our %s with the command that was provided in, because this could be one of two commands, either the BG or the FG, as we saw inside of the tiny shell output. And then again, once we're done that, we need to make sure that the rest of the function after this does not get executed. So we'll just return out of the function from here. Let's save that. Let us clear this. Let's make sure that we can compile this code. Every time we make a change, we should recompile. And then we will go ahead and test our function out. Let's test the reference shell. So let's do the reference shell. And so here it's going to spit out all this. Up to this point, this is where we're at. This is the next two pieces we're going to be looking for. This FG command requires PID or job ID argument, and this BG command requires PID or job ID argument. Okay, so let us now run the test for just our tiny shell, and we can see, yeah, look at this. Now we're getting this output here up to BG command requires PID is the same as here. That's excellent. So now we can examine the next state. Okay, I'm going to clear this just to keep my terminal nice and clear. Okay, so moving back to my slide deck, you can see, okay, yeah, so far, all of the output from our observed behavior matches up to our reference tiny shell up until now. These new set of error messages where it says FG argument must be a PID or %job ID, and very similar, BG argument must be a PID or job ID. So clearly, these are these instances when we are trying to pass in FG and BG with just a alphanumeric letter or something that does not conform to our expected input for either a PID or a job ID. Clearly, the ones we just saw were when we just called BG and FG without any parameter. Now here, though, we have to check to see if the parameter is valid. What is a valid parameter? Well, if it either is a number, right? So this is technically valid. It just might not exist. So if it's a process ID, it's just going to be an integer value. If it's a job ID, the first character of the argument string is going to be a %sign. And then the rest of that string will then be integers that represent the ID for that job. Okay, so we can check to see if it's neither of those two things. And if it's neither of those two things, then we can say, okay, that is, you gave us a improper argument for the job. So let's see here. So this is where we last left off. So the logic on how this could look then is we can just simply check those two different conditions inside of a selection statement. So we can check inside of our parameter, which is the argument that's passed to the command. We can look at the very first character. So that's the character at index 0. And if that character is not equal to a %sign, then it's like, okay, that could be, that means that it's not a job ID. And if the parameter, if inside of our parameter, the first value is at index 0. So the very first character is not a digit. So there's a system call isDigit where we can pass it in a text character, and it will let us know if it is a numerical digit. If this returns false, then this is a way of determining if that was a legal value or not. Now, I'm gonna stop us here and just say I am doing the simplest implementation possible just to pass these traces. Clearly, if you look at this logic, there are conditions that can occur that are edge cases that are not captured by this logic. And so I would leave it to you to make the error handling more robust, right? My endeavor here is not to create a very robust, resilient, fault-tolerant tiny shell. It's to show you how we can walk through this process and what considerations we have to put into in order to pass these traces. But when you see these conditions from the tiny shell, what you should really endeavor to do is actually try to capture all of the potential edge cases that can lead to malformed, bad, faulty commands and be able to go ahead and respond to that. So I'm just highlighting that this logic works for our trace, but clearly you could probably look at this and see, oh, I can send this type of input and this shell implementation is not going to catch that. And you're right. That is absolutely correct. And if you see that, see if you can't find ways to make a more sophisticated logic to be able to catch those instances you might consider. Anyway, with that said, these are the conditions that we need just to guarantee that we have a job ID for our trace checks. And so in response to that, if it isn't a job ID, and if it's not a process ID, then we're going to print our message. And then, of course, what we need to do is also return out of this function because we don't want to execute any of the following logic because we don't have anything that is suitable to be able to do that, right? We don't have a job ID or a process ID, so we can't do anything. Okay, so let me jump here. So now let me do this if check. If, there we go. And so what we said we were going to do here is if the index of param0 is not equal to a %. And so keep in mind, I'm going to go ahead and use a character for comparison because we're indexing to get into a character string, a character array to get a single character for comparison. And we need to check two different conditions. So if it's neither a % character and it's that first character is not a digit, so we'll call that system call isDigit, and then we'll check the not condition on that. So, and it's that first character is not a digit, well, then that's not a job ID. So it's either got that first character either has to be a digit or it has to be a %. Okay, so in this instance, let's go ahead and have our error message. And let's do it. What was it? %ASK:. So that's going to be the command, and it's going to be the argument must be PID and then %. And just a highlight in case you hadn't seen this before, since we're using formatted print statements, and since the special character, the flag character, the sentinel character that represents, hey, we're about to insert a special character into the string. This isn't a normal character, is the %. Well, then the % is normally followed with something like an S to represent, oh, this will be a placeholder for a string, or %D, oh, that's going to be a placeholder for a decimal. Well, if we want to actually print a percent sign, well, since it's already marked as a special character, we have to do %%, and it'll print out a single percent sign. So just in case you were unfamiliar with the syntax of %% in a formatted print statement, that's just what's happening there. Okay, and then we have our job ID, and then we have our new line character. And then what we'll do is go ahead and then pass in that command to replace this placeholder value here. And again, we cannot forget, we need to have this return statement. Okay, we will save that. Now let's go here and let's compile our code. Our code is compiled. Now let's compare. So here, let us make the reference test. There we go. So we get our echo, we get the bogus, we get the call for our MySpin application to run in the background. We have our foreground and background requires a PID. So that's just when we call them without any argument. We get these errors. Okay, this is your argument must be a PID or job ID. So this is the set of error messages we're trying to attempt to get on our shell at this time. So let's go ahead and see if we get that. Let's go ahead and make on just our test shell. So we get our echo, we get our error message where bogus command not found. We successfully go ahead and call my MySpin in the background. We have our foreground command requires PID, background command requires PID, and these are the two new, which look perfect. They're in line with exactly where we're at here. And so if we wanted to validate and verify, we can see, yeah. So the first 7 lines of output now match 1-to-1. So once we do that, we can then look at the output from our reference shell. We can see, okay, what is the next set of lines that we're not getting? We can see, okay, it's going to be these no such process 9999. We're moving it to the foreground. We're moving it to the background. We're calling both BG and FG on a non-existent process ID. So now recall again, as just like I stated earlier, we're not going to be super robust in our error handling. We weren't super robust when we initially implemented our do BG FG function, because all this time we've been saying a valid parameter for BG and FG is a job ID or a process ID. But up until this time, we've never actually implemented the logic for being able to use a process ID for BG and FG. So we'll have to implement that. And at the same time, while implementing that, we'll also have to make that check to see if that process ID is valid or not. So what's the logic that's going to drive this? Well, first of all, recall, let's go back here into our do BG FG. So recall that there's 3 pieces of data that we, local data that we kind of initially set up for this function. There's going to be a job pointer that we set to null. And so that's the process job that we're going to update to either go to the background or the foreground and then send it a signal to continue. There's going to be the command from our argument array, which is going to be at index 0, and there's going to be the parameter that's associated with that command inside of our argument array. Okay, with that said, what we need to do is, well, first of all, let's do the logic that's going to allow us to go ahead and just use a process ID to update job state. So here, so underneath these errors here, so provided we don't exit out of our function because we don't have a parameter or because our parameter is illegal, it's invalid, let's then check right ahead of this line where we last implemented, if it's for a job ID, let's check for a process ID. So what we're going to do here is we're going to do the inverse of the check if it was invalid. So just like for a job ID, we were checking, okay, is the first character in our parameter string a %sign? And if it is, oh, that means that's a job ID. We're going to go ahead and grab the address of that job ID starting at index 1, right? We're going to get that character pointer for that. We're going to send that to that system call A to I. So from ASCII to an integer value, that'll give us our job ID number, and then we can get the job from that and then set that job from there. So if that's the concept that drives how we do that with job ID, well, and the reason why we knew it wasn't valid for a job ID is if it's not, that first character is not a percent sign. Well, if that first character is not a digit, that means if it is a digit, then that's our process ID. So that's what we're going to check. So inside of here, we're going to call the system function is digit. And then inside of our param, we'll just check the first character to see if that first character is a digit. If it is, then we'll treat that as our job ID. Excellent. Now, the next thing I want to do is I can go ahead and let's grab the PID then. So what we can do is we are going, so since we know that this parameter is a digit, so if the first character is a digit, we're going to assume all the other characters are a digit. So then we're just going to send the param to the system call A to I to convert the ASCII text into an integer. Now, again, that's relatively brittle, but we're just going to make that assumption for this implementation. Okay, so that should return us an integer that represents our PID, our process ID. Okay, so once we have that, then we can say, okay, let's take that local variable, that variable that we had defined at the top of our function, job P, our job process, which is null, and we're actually going to now assign it with get job and PID. So we can use the PID to get a job from our job list. And so what we're going to do is we're going to pass it our PID to do that. Okay, so here now, if you look, we're in parity with our job ID logic, and I'm sorry, our process ID logic. This is for the process, and this is our job ID logic on how to get a job. And recall then after that, we oscillate and determine if it's a background job or a foreground job. We do something in response to that. Okay, so this now is the implementation that actually satisfies being able to use either a process ID or a job ID to go ahead and move to the next set of logics into this function. But recall, we also have to add in that error message. If I stop now, we can look at this. If I get job PID, let me make sure that I have called this correctly. Let's see, get job. Let's see. Okay, let's take a look. If A2I get job PID. Oh, I also need to pass in jobs. So recall that get job PID requires 2 arguments, the jobs array, and then a PID, just like get job JID requires a jobs array and a JID. So can't forget the argument list. If I was good, I would have looked at the API before making that call. If that's okay. And now let's go ahead and try to make that. And so here we're going to echo out our comment. We're going to go ahead, have our bogus app. We're going to have the background application running for 4 seconds, my spin. We get the FG command requires, BG command requires. We get the FG and BG, and then look at this. We're just kind of hanging here indefinitely on this instance because we've done something. We're not doing anything in response to this here. And so, okay, finally. So after finally our 4 seconds, it finally clears out. But notice we didn't get the error message that we anticipate because we didn't implement the error message. So now what we need to do here is, but notice it did run. It did run all the way through, but it didn't interrupt any jobs, didn't stop jobs, and move things, didn't print errors. So what we now want to do is we now want to update this new implementation here such that if job is null, if we go to job PID, we give it this PID and it doesn't give us back anything, because recall this function get job PID, and we can take a look at it. Get job PID. Let's take a look at this function. We can see that it's given the jobs array, it's given a PID, it's going to go through and find the job where that PID matches inside of that structure. But if it doesn't find anything, it's going to return a null. So we default our job process, our job P, with null, and then this could potentially return a null if it doesn't exist. So let's go back to the do BG FG. Let's jump to that. And so that we can update our logic. So here, then, that means that after we try to attempt to set this job P, we need to check to make sure it actually has a value. And if it doesn't, then that means that that process did not exist inside of our jobs list. So here, what we can do here is we check job P is equal to null. Perfect. And so if that doesn't get set, we're going to do that print statement. So here we're going to print. Now the if I remember correctly, the format of this print statement has our process ID inside of parentheses, and then we'll just print out a integer value, so a decimal value, %d. And then we're going to do a colon, and then the error message is going to be no such process. And then we will do a new line, and then we are going to replace that %d with the PID, since that is what we're attempting to use to get our job ID. And when that occurs, again, we don't want to try to execute the logic that tries to actually do the BG or FG. So we will simply then return out of this function if we do get into this exceptional case. So now let's go to our terminal. Let's clear this. Let's recompile. Let's make our reference test on 15. And then what we will do is we will make our own test. We could see this is the output we're going to be looking at this step. Let's see if ours looks the same up to that point. And yeah, it looks like that looks great. So here, these first lines now look very similar to all of these lines here. And again, it's still executing because we're not doing anything in terms of these final kind of steps of being able to move things to the background, as we'll see, because there are some commands that are illegal, and that's what's happening there. Okay. So at this point, we can say, after that implementation, yeah, the first 9 lines of output from our tiny shell task should now match the reference shell task. So now the next line is going to be a 10th line where it's going to attempt to use an invalid job ID to try to go ahead and move a, I believe it was, let's jump to it. I believe it was this one here. So here, so we've successfully done this amount of the directives inside of our test case. So this is the next output that should generate an error. We're going to try to take this background process of my spin, and we're going to try, well, not this one. This is why we're hanging for a couple seconds, because it's successfully doing this foreground move of our job ID. So recall that there's no job ID 2, right? The only job ID we have is this my spin. So we're trying to move a job ID of 2 into the foreground, which should result in an error message. And so that's what we're not getting currently. So we're going to have to update that. So clearly, what we're going to have to do to update that is very similar to what we just did for our process ID. When after we set our job ID, we're going to check, okay, did we actually get a job instance? Did we actually get a job reference based off of the job ID? If our job is still null, that means we did not, which means we have to print a error message to alert the user, hey, you gave us an invalid job ID, or you gave us a job ID that is non-existent, and then we'll return out of the logic for that as well. Because the core concept that drives both the selection statement for the process ID and the selection statement for the job ID is to set the job P variable so that we can do something interesting with it. So if at either instance it's not set, then we have to exit out with an error. Okay, so that's going to be in this part of the logic here. So here I can just go ahead and check if my job P is equal to null. Oops, I can't have a. So that's going to be our check there. Then what we want to do is we need to go ahead and print out that message then. So we're going to do printf. And then the format of this message is it's going to be a percent, right? So the percent sign, and then it's going to be whatever the ID value, the job ID value is given. So we're going to give it the same kind of formatting that it expects the user to provide inside of our error message. So the first 2% signs are going to print a single percent sign, and then that %d is going to replace with the integer value that got passed in this instance, the value 2. Then we're going to put the message, no such job, and then we'll do a new line character. And then we will pass it the JID, and then we have to return out. Perfect. And then once we do that, we can go here, we can clear this. Nope, we can clear this. Yes, we can go ahead and compile our code, make sure there's no issues or errors or syntax mistakes. Then what we'll do is we'll print out our reference test. So we get the echo of our header comment. And so the thing we're interested here is, right, this no such job. And so here, let's actually now make our test. And we can see here, by completing that, so now we have %no. So this is on our reference sum. Let me actually increase this so we can actually look at it. So bogus to bogus, right? The successful running of our background application in the background, right? That matches. Here is FG, BG command requires PID or JID. Yeah, that's here. Then we have the FG, BG argument must be a PID or job ID. Yep, that matches this. This is going to be no such process. That matches here. And now the newest things is, and actually let's look at it. So we have our no job ID. I see that. A job 1 stop by signal. So that's the stop signal that we send. Then no such job can be moved into the background. Then we successfully move our job 1 to the list, and then we are calling in our jobs. So actually that and that match. So that was the last error that was preventing us from actually getting 100% compliance with our reference test. So now if we compare our reference test to our tiny shell test, we should actually get all the same lines. They should be compliant. We should be done now. So now, just to ensure that we're done, we should just look at the fact that whether we pass a test or not, I mean, we have the same output, so we should, but we will validate that by just calling our tester application to go ahead and accumulate and sum up the amount of points we've accrued. And so while we do this, what you'll likely see is we might pass more than just test 15 too. So if we do, we'll take and examine as to why. And I think it'll be very evident why that's the case. And while we wait for that, let's take a look at a preview with the expectation that this is going to pass. So when we would continue on, trace 16, if we examine trace 16, it just puts all the other traces together, which means so long as we followed the guidelines put forth in these test directives in traces 1 through 15, this is just doing a series of combination calls to our tiny shell. And so here we can see, okay, so in order for trace 16 to properly pass, we have to have the appropriate error message if we try to call this bogus application. We have to be able to put this MySpin application into the foreground for 10 seconds. We have to successfully be able to sleep it, which is going to send a stop signal to the foreground application. I'm sorry, not that. Send an interrupt signal. The sleep is for the test hardness, just to sleep for 1 second. We need to successfully interrupt that MySpin application, though, because the idea is that we're not going to wait 10 seconds for that. It's testing our ability to actually interrupt that application. Then we need to successfully put my MySpin application for 3 seconds as a background application. We're going to wait a second, and then we're going to put another background application in the background for 4 seconds. We're going to call jobs to make sure that the jobs are printing out all the current jobs. Then what we can do is, since we should have a job 1 ID, we're going to move that into the foreground, which is then going to send it a continue signal. Our job 1 should be this one right here. We're going to sleep, and then we're going to send a stop signal to the entire process group. And then we're going to check our jobs. And then what we're going to go ahead and do is set as a background our job ID of 3. And then our job ID of 1, and then we'll check jobs, and then our foreground of 1, and then we'll do a quit. And so let's see here, we're done passing this. So I just want to see where we're at. Actually, it says that let's see, let's do a diff. Saying I failed. So let's see here. Let's do a diff, make sure that all my outputs are correct. So let's make our test 15, and let's make test 15. So sometimes, because the validation is based on the exact formatting of our strings, let's verify that there's no differences between these actual outputs except for the process ID numbers, which is going to be what we expect. Okay, so clearly the calls to whether it's tiny shell or whether it's the reference shell are going to be different. That's expected. The only difference here, if we look at it, is actually the process ID. That's fine. Oh, here we go. FG argument must be PID or job ID. So this should not be different. So let me see. What am I seeing here? FG, BG, it's that argument must be a PID or job ID. Argument must be a PID. This, and then this is fine. And then, oh yeah, so something is going on here. So I just have to fix this. I'm not seeing instantly what that is, though. Argument looks correct. Must be. Oh, I see. Must be a PID. Okay. Must be a PID or job ID. Okay. So again, you could see that the logic is there, but just as equally important, we have to match word for word, letter for letter, symbol by symbol, the exact expectation of what these error messages are from our reference cell. So we have to pay a lot of attention to that, which is why it's good to check these diffs. Okay, so now here, yeah, it does not say that anymore. Let's clear that. And so here, let me just run this in the background one more time just to confirm. And this again is why I wanted to check to make sure that I accrued all the accumulated points, just to make sure I didn't have some little typo such as that in one of my error messages. This is the particular trace where you might fall into that pit in particular. Okay, so while that's working, let's actually take a look. Let's go back and talk about trace 16 a little bit more. We can see that trace 16 is simply just putting all the concepts that we've implemented in our prior 15 traces when we look at all these directives. So if we've done everything successfully, we can see we have all of our command descriptions here. If we've done everything successfully, then we should automatically pass that. And so we can actually see, based off of the output, that all of our observed behavior should match with our expected behavior from the get-go. We can say we're going to get that bogus command not found because that's not a real application. Then we're going to successfully go ahead and run that foreground application. Now remember, since it's a foreground application, the shell is going to just wait, but then we're going to send an interrupt signal. When we send the interrupt signal, it prints out a message, hey, that job 1 was terminated by signal 2, which we get here. Then we're going to go ahead and do 2 jobs in the background, right? So we've terminated that first job, but now we have a background job, mySpin3, and when we do a background job, it prints that to our display. We'll also go ahead and do another background job. So now we'll have 2 jobs in our job list. And now if we do our jobs printout, it should say, oh, there's 2 jobs running in the background, which we get here. Now we're going to go ahead and stop a job. That's let's see here. That's going to be, we can see where we go ahead and stop. And so we can see now that when we go ahead and check to our jobs list, we can see that there's 1 stop job and 1 running job. And we can see that we did and so that's what we have here. And now we're going to try to move here into the background a job 3. So we should get an error message that we just recently implemented in trace 15, no such job. And so then what we're going to do is then we're going to successfully move into the foreground, job 1, right? And so that's going to actually happen. And then we can see that, oh, that sends a continue signal to the job that was stopped. So now it's going to continue running. So when I call my jobs list at the end, it's going to show me the same output here and here. So no changes should be made to our shell to successfully complete trace 16. And if we look at our accumulated points, we have successfully gotten the pass on our trace 15, but we've also have the pass on our trace 16 because, hey, our trace 16 is just doing everything from traces 1 through 15. And then notice, because of our implementation, we even get a pass on trace 17. We don't actually get a fail until we get to trace 18, 19, and 20. We're going to look at that in just a moment, but then we're going to stop this particular lecture. Let's just take a look at trace 17 to understand why we're passing that. This actually is just going to check whether we can handle the stop signal or the interrupt signal that comes from other processes instead of the terminal. And because we used the signal handlers in the way that we did, it does go ahead and stop. It does go ahead and utilize the signals that come from other processes instead of the terminal itself. So here it's using the myStop application. To be able to do that, you can see a call from my stop and my interrupt. It's going to send those signals into our shell. So we could say that the expected output would be that job 1 stopped by signal 20. And then we're going to run this my stop job. And then we're going to say that, yeah, that this job 2 was terminated by signal 2. And we're going to get the exact same output because of the way we implemented our signal handlers. And so what that means is that we have successfully implemented everything up until trace 18, which is really going to be the traces that start to focus on redirects. And so we will pick that up in our next lecture. Thank you for watching. If you have any questions, please let me know.